Hi, welcome back. And see, in today's session, we are continuing the topic, continuing the problems what we have started in the previous session. First question for this session. Given a function if as f of x is equal to 5x plus 4 for all x belongs to R, g is the other function which is mapped from R to R. Is the inverse of the function. F of x is one function and g is f of x is defined like this. G is the other function which is mapped from real number to real number. I have to find out the inverse of that function. So if I want the inverse, if g is the inverse of the function, then what do? I have to take f of x is equal to 5x plus 4, equate that to y. Okay, so 5x plus 4 equal to y means 5x is equal to y minus 4 and x is equal to y minus 4 divided by 5. This is in terms of y I have written. See these answers, which one is matching for this. This is the inverse what I am getting and this belongs to real number. Okay, so if you are seeing that answer, which one is matching with this? Because you are writing g of x, answer are in terms of x. Okay, if I am writing this in terms of x, then I have x minus 4 divided by 5 as the answer. Option B will be your right answer. Got it? So what we have to do here, when you have to find the inverse, you have to equate it to y. 5x plus 4 is equal to y and 5x is equal to y minus 4. X is the value what you are getting and that is this one, y minus 4 divided by 5. So that is here. Got it? Okay. Next question. Second one. If f be the greatest integer function defined as, f is the greatest integer function and g is the modulus function. Greatest integer function already you have studied in class 11th and in relation functions also I have explained you how greatest integer function it will be there, right? And g of x is a mod function. So when you have both the functions defined, mod function is defined like this, then I have to find out value of g composition f of minus 5 by 4. G composition f of minus 5 by 4 if I want, and the options are here. If I want g composition f of minus 5 by 4, g of f of minus 5 by 4 means how much? Minus 5 by 4 means minus 1.25 I get. So now I have to find out g of f of minus 1.25. Correct? F of minus 1.25 means g of f of this value. What is f of x? That is the greatest integer function. Now tell me what will be greatest integer of 1.25. What will be greatest integer of minus 1.25? Minus 2. So this value will be minus 2. Now if I am taking f of the value, that means greatest integer of minus 1.25, that is giving me 2. I have to put 2 here. Correct? Minus 2. Correct? G of minus 2. Now g of minus 2 means g of x is mod x. Whatever is here, same thing you have to write inside the mod. Now g of x is mod x. G of minus 2 will be mod of minus 2. Right? Mod of minus 2 value will be, what is the speciality of mod? Whatever, how much ever negative you talk, I will be positive. This is the nature of modulus. How much ever negative you talk, I will be positive. So if you have given me negative number also, I will convert that to positive. So it will be 2. Both are there in answer. Be very careful. Mod is there. Mod will bring you always positive value. So whenever I have put negative also, I will get positive. So option A. It won't be 2. It won't be minus 2. It won't be second option. It will be 2. Understood? So composition of function is there. One function is inside the other one. One is in greatest integer. Other one is mod. Other way also they can ask you. Okay. They can ask you f of g of x also for any particular value. Method will be same. Understood? Okay. Next problem. Third Third one, the domain of the function defined by f of x is equal to sine inverse of under root you have x minus 1. Under root x minus 1 is there. They're asking you domain of the function and options are here. Fatafat you write the options and we will solve this and we'll see what we are going to get. Very simple question. Domain of the function where you have sine inverse. Okay. When you have sine inverse of any value, where that lies, what is the range of that? What is the range of that? Whenever you have sine inverse of any value, that lies between minus 1 to 1. That means this value what you have here should belong to root of x minus 1 is there, right? The value what you have that belongs to this, that lies between minus 1 to 1. So minimum it can reach minus 1, maximum it can go only up to 1. That is for sine inverse, right? Now if I take only the value, this is of the root. If I take only the value, under root whatever I have, it has to be positive. That we know. Under root if I get negative, that becomes complex number, that becomes imaginary. So I have to avoid that, because function we are dealing only with the real value functions, correct? Now after having the root, inside the root, if I have to get only positive, then I can restrict this to 0 to 1, correct? So it's like this now. I have minus 1 till 1. Okay, so I have to restrict that to 0 to 1 because all this value are negative. I have to take only 0 to 1 where I am getting only positive because root is there. So easily I can write that whatever is there under this root has to be positive. So it has to lie between 0 and 1. Now I don't want this minus 1. I want to know the domain of the function. Domain means what value of x I can give. So giving is a domain. What you get is a range, correct? So what I can give means that I don't want this minus 1. So I'll take plus 1 here. If I take plus 1, it will be minus 1 plus 1 and it will be plus 1 means 2. So where it lies? See the options where you have 1 to 2 with a square brackets because we have equals here. Yes, option A is correct. Okay, 1 to 2, that is the domain of this function. Whatever question it will be, layer by layer you have to solve. You are solving competitive exam questions, right? So if this is there, when you have trigonometric questions, inverse trigonometric, always think of range. Always that will help you. Got it? Within no minute you can solve such problems when you think of the inverse trigonometric functions, domain and range. Most of the inverse trigonometric functions answer lies in the range only. Okay, first work on that range. Got it? Superb. Next one. Next one, write down the question. Every class I tell this, whenever you come to math class, you bring your pen, you bring your book, and so that you can copy the question and we can together solve it. How many of you are following this? Write down the question. If f of x is equal to x square, if f of x is equal to x square, mapped from n to r, natural number to real numbers, then it is, see what kind of function is this? Is it 1-1 function? Is it onto function? Or is it both 1-1 and onto? Or will it be none of these? Yeah. Tell me. F of x is equal to x square is the function what they have given and it is mapped from n to r. N to r, natural to real number. Then tell me which type of function is this? You have to check only these two, right? So you have to check for 1, 1 and check for onto function. X value have to think. X value are here. Okay, the domain part. This becomes domain and this is codomain. If range is equal to codomain, that becomes onto. Correct? If you have forgotten what is 1, 1 and onto, this is a quick revision for that. Range is equal to codomain will bring you the onto function, and 1, 1 means one element is related to one element. One element to one element, that becomes 1, 1 function. Now suppose for this function, if I am writing the mapping, let's take few numbers and check. Because anyway for x I have to take natural number. Natural number starts from 1, so I have started from 1. If I am taking 1, I will get 1. I have taken 2, 2 square, I will get 4. If I have taken 3, I will get 9. If I have taken 4, I will get 16. Taken 5, I will get 25. So one is the number, other one is the square of the number. Is that clear? This is set A and B. One is the number and other one is the set of square of the number. So how it is related? 1 is related to 1, 2 is related to 4, 3, 4, 9, 4, 4, 16, 5, 4, 25. So can you tell this is 1, 1 function? See, don't forget that codomain is R. You will have all the negatives here. -3, -2, decimals. Everything will be there in R. Okay. But what are related? Only these numbers. So can I tell that range and codomain are equal? How many of you think range and codomain are equal in this? I will not think, because I know the concept. Codomain will have all the real numbers and range will have only the square of the numbers, and square of the numbers cannot be negative, so I am getting only positive this side. Agreed? So range and codomain are not equal. So range is a subset of codomain. When it is a subset of codomain, then it won't be onto. Rule out the option. When it is not onto, it can't be both. Right? When it is not onto, it can't be both. Agreed? Now question is of these two. If it is a 1, 1, then it won't come, none of this. If it is not a 1, 1, then it will be none of this. Agreed? Now check for a 1, 1. One element is related to one element only. Correct? So because of natural number, otherwise not. If it is a real number, you can't tell the same. If it is a natural number, then no question of taking negatives. Agreed? So if you are going by steps also, this is about the mapping, where you can decide whether it is a 1, 1 or not. If you are going by numbers also, it will be like this. F of x1 is equal to f of x2. x1 square is equal to x2 square. x1 is equal to, only plus will come. Plus or minus will not come here because we are dealing with the natural number this side. So here we will get only x2. Okay, perfect. So you have taken imagers are equal, then we are telling the elements are equal. When you are having images equal, when you are getting elements are same, then we can tell f is 1, 1 function. We have done so many questions on 1, 1 function. This is very simple for us. So by mapping also you can understand it is 1, 1. One element is related to one element. Or else this is the mathematical steps, the procedure we have. So by all the argument we can tell that answer is 1, 1. It is not both, it is not none of this, it is not onto, but it is 1, 1 function. Is this clear for you? Agreed? Okay. Next one.